Hi scholars, let's look at TEK 4.4e. It says I can represent the quotient of a 4-digit whole number divided by a 1-digit whole number using arrays, area models, and equations. Now, if you saw my other video on representing the product of a 2-digit by 2-digit number, we also represented it through arrays, area models, and equations. An array is rows and columns, and like it's a faster way to multiply. Area models is very similar, but it's like broken up. So like, I'm just going to use this. This makes the most sense. So this is like 8 plus 2 and then times 10 or something like that. You've broken it up into parts. And then the equation is the math problem. So let's get started. So we always think of an array like an arrangement. We always think of it as an arrangement of, sorry, that was my phone. We always think of an arrangement of rows and columns. And when those rows and columns are multiplied, that gives us the total. So like, I'm just going to do a basic example. I have 3 rows and 4 columns. So instead of counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I can do 3 times 4, that equals 12. So 12 is the product. 3 and 4 are the factors. Now, I also, in my other video for division, explained that the division symbol actually looks like this, because you want to think of this as the array, and this is the total number of pieces in that array. And you're telling what one side is and what the other side is. So it's supposed to look exactly like this. You are thinking that there are 12 pieces, and you have them in 3 rows. How many columns are there? And so that kind of gives us the setup. Now sometimes our arrangement might not work perfectly, and there will be leftovers. So I will also explain that too. So let's look at a visual using manipulatives. So I have here, so let's do 1, 2, 3, 4 columns, 3 rows, okay, and then we'll fill in the rest. So here is 12 pieces divided into 3 rows. Each row has 4, or how do I explain it? I have 12 pieces that are in 3 rows. Each row has 4. 1, 2, 3, 4. So that's a row. 1, 2, 3, 4. That's a row. 1, 2, 3, 4. That's a row. So this array is not only a representation of 3 times 4, it's also a representation of 12 divided by 3 equals 4, or 12 divided by 4 equals 3, which matches up with this division problem. Now, I want to explain a division problem with a remainder, because it's not always going to be perfect. So suppose I have 13 divided by 3. So what you're basically saying is I have an array that I want it to have 13 pieces, and I want there to be 3 rows. How many would be in each row? So if you look at it like this, I'm going to purposely put that in blue. So this is 13 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So when you're doing the division, you're saying 3 goes into 1, none. I always have my students put like a little X. 3 goes into 13 4 times. 4 times 3 is 12. 1 left over, 4 remainder 1. If you look at this division problem very carefully, You are saying, I always tell this story to my students, like someone is saying, hey, I want an array, I want 13 in there, and I want 3 rows. And it's kind of like when you solve the problem, you say, well, the best I can do if you want 3 is 12, a 3 by 12. And then there will be 1 piece left over. So that 12 plus 1 is your 13 pieces that they originally asked you to put in an array, but this is the best you can do. So your representation of the division problem using an array would look like this. You would have your 4 rows or 4 columns as your answer, and then 1 remainder. So if the answer is 4 remainder 1, which is what we got from our division problem, you need to see 4 groups and 1 left over. If you see it this way, this is incorrect because they are dividing by 3. Or actually, no, this is correct. I'm so sorry. You're dividing by 3 into 3 groups. There are 4 in each group with 1 left over. So sorry about the confusion. Let's look at another example. Okay, so suppose I have 21 somehow put in an array with 4 rows. How many in each row and how many left over? So you have to solve. 4 goes into 21 5 times. 5 times 4 is 20. So this is the best your array can be. There can be 20. There will be 1 left over. So you'll have a 4 by 5 with 20 in there, and then there will be like a leftover because there's 21 total pieces, but the best you can put in an array is 20. So here's what your representation would look like in an array setup. So we said 4 rows, 5 in each row, 1 piece left over. So if I had like a long division problem, like 327 divided by, I don't know, 8. You know, I don't have 327 little squares, or maybe I do. I don't know. I have a pretty big bucket of it. Look at that. Okay, but basically, you know, your array, you just need to picture that there's 8 over here, and then you need to figure out how many would be on the top. So 8 goes into 32 4 times. Bring the 7 down. 8 goes into 7 0 times. So 40 remainder 7 is the best you can. You can make an 8 by 40 array, and there will be 7 left over on the side. So here's what the array would look like. And I'm just going to draw like your basic picture. 1, 2, 3, 4, 5, 6, 7, 8. I don't think I have the energy to draw this 40 times or 39 lines, but you get the idea. And then there will be 7 on the side because you just need 1 more to make another group. So there's 7 left over. So that's an example of what arrays would look like. You know, the higher the number, obviously the larger the array. You can basically make any array to represent that. You could even have like something like this and 40 in each group. You could even have something like that, and then you will have 7 little pieces on the side. You know, I can't go into detailed drawings, but you know, you might get questions like that on your assignment. So this is definitely something you might want to practice just to kind of get the hang of it. Do the division problem so you can figure out the dimensions, the length and the width, and then, you know, draw your extra pieces on the side. Main thing I really recommend is, like, if they say which of the following shows 327 divided by 8 equals 40 remainder 7, make sure you see 40 in each group represented, or if it's 327 divided by 40, make sure you see 8 in each group. Sometimes the picture can be look very close to it, but make sure you're counting the number of groups. Okay, so you get arrays, so let's talk more about area models. So suppose you have 69 divided by 3, okay? So I'm going to go ahead and just solve real quick. So the answer is 23. So to represent that, I know the array is going to be a 3 by 23. I know I just said let's not talk about arrays, let's talk about area models. Well, area models come from arrays. So I'm going to break up that 23 into 20 plus 3. Okay, I'm not going to break up this 3 though. And so I'm going to show a 20 by 3. This is a 20 by 3 array, so that's 60. And then if this is 3, then this side is 3. So this is a 3 by 3, so that equals 9. So 60 plus 9 equals 69, which was my original math problem. It was 69 divided by 3 equals 23. So here's 69 divided by 3 equals 23. I'm just breaking it up into area models and using distributive property. This is division using distributive property. Now, I'm going to go over some examples that I used in another video that essentially show the same thing. Okay, another example I wanted to do was 225 divided by 15, and the answer is 15. I know you're not expected to do 3-digit divided by 2-digit, but this is a perfect square that I used as an example in another video. So just so you can kind of get the idea. So here is the area model. This entire thing is 225 squares. It's a 15 by 15, which I've shown through the equation. And then I broke up the 15 to 10 plus 5 and 10 plus 5. And then when you look at this section, this is a 10 by 10. And then you look at this section, this is a 5 by 10. This one is a 5 by 5. And this is a 10 by 5. So this is an area model that represents 225 divided by 15, or 15 times 15 equals 225. Like division and multiplication work together. Let's look at another example. Let's see here. Here is one. It is, let's see, 200, 300, 380. This is 399 divided by 19, I believe. And the answer is 21. Let me make sure that is correct. Yes, it is 399. So we know our array is going to have 399 in the inside, and there's going to be a 19 by 21. Now, since they want an area model, you would break up the 20 and the 1 and the 19 as a 10 and a 9. Okay, so here is the array and the area model since I broke up the array. So here's my 20 and 1, and here's my 10 and 9. My 20 and 10 make 200. My 1 and 10 make 10. My 9 and 20 make 180, and my 9 by 1 make 9. So the total of all 4 sections is 399. So this is 399 divided by 19, which equals 21. I wanted to show one more example. 764 divided by 9 equals 84, remainder 8. So you would have a 9 by 84, which would actually have like 756 pieces here, and then you would have 8 pieces right here. So just some different ways for you to see division represented.